Hello, my name is Bob D. Hilster, and I am your particle model guru. I'm here today to talk about Young's double slit experiment. In particular, I'm talking about diffraction. Uh, in two previous videos, I suggested that you watch this video. It's a very good video where Jim Al-Khalili talks about the double slit and explains a lot of it, but there are parts of that quantum mechanics cannot explain. I have presented two previous videos. The first one was wave versus particle, where I talked about wave-particle duality that the standard model uses. And I also talked about light as not being polarized light, but being layered and unlayered light. And then the second one was part one of explaining the double slit, and where I explained interference, how the particle model of light could actually combine on a target screen and set up an interference pattern. The interference pattern of light is often compared to that of water and sound. This is a picture of a literal photograph of linear waves hitting a barrier with two slits, and then as the water goes through the two slits, it sets up a wave pattern showing that water bends as it goes around this barrier. So that's it's being compared, but light as a wave actually needs a medium. Water waves needs a medium, and that medium is water, and it causes not causes, but motion of the water will give you waves, or random waves, or linear waves, or waves that spread out. Sound needs air as a medium, and it's the motion of the air, regular motion of the air, that causes sound and noise that we hear. Light, well, they don't say too much about light as an ether. People do talk about it, but you have to see, you see down here when you look up ether on the internet, since the development of special relativity, theories using a substantial ether fell out of use in modern physics and were replaced by more abstract models. Oh, well, what's that? What's abstract model? Don't know. There's no explanation as what the what ether is. What's this medium that's required to make it act like a wave? But it does. Don't worry about it. It does act like a wave. So light does bend. We see light bend around a barrier. But in this particular graphic, light as a particle, if we continue light as a particle, and they claim light is both particle and wave, wave-particle duality, if it acts like a particle, it can't bend, because particles must go in a straight line, whereas waves around a barrier can actually bend. This is the exact reason. When these particles hit the target screen, or even when these waves hit the target screen, they act like a particle. So they know that there's a particle effect and a wave effect. But ultimately they're saying particles do not bend around barriers. Well, the particle model for light is a stream of particle and does not need a medium. These particles are moving to the right at speed c. There is a peak, a lot of particles at the peak, very few particles at the valley, more particles at the peak. And this is the wavelength of this particular stream of particles. Does not need a medium, and it's just particles only. Back in a while, I did a video on two gravities, titled Two Gravities, and in that I concluded that by analyzing refraction, that there could be a G2 force field that is the cause of refraction. That's what the particle model is proposing. There is a separate G2 force a field of particles that causes light to bend. At the same time, whoa, excuse me, I hit the button. At the same time, I was comparing it to the G1 force field around the Earth. The G1 force field is the Newtonian force field around the Earth, holding an atmosphere and holding us in and all other objects. But there isn't just a G1 force field around the Earth. There's also a G2 force field. Why is that? Because light coming from the sun hits our atmosphere, comes from the sun, hits our atmosphere, and refracts. And if refraction is caused by a G2 force field, there must be a G2 force field around the Earth causing refraction and hence causing our sky to be blue. Well, there's a G1 and G2 force field around a prism, because if I'm holding the prism and I let go, it falls towards the center of the Earth. So there's a G2 force field, G1 force field around the prism, and a G2 force field which causes light to bend. So we're going to look at the G2 force field. This is only one slit, but I'm going to make a point here about the fact that the G1 particle is the light. Streams of particles passing through the slit, and they're moving at speed c. The G2 particle force field, in one of my previous videos, claim has to move faster than light. Now, my estimate is c squared. That's just an estimate. I don't know that that's true, but I use that as just a general number, indicating that it must go much faster than light if it's going to cause it to bend, cause it to accelerate, cause it to decelerate. This G2 particle has to move very fast, faster than light. In any case, if you're going to follow the G2 particle through this screen from this way and then this way in sort of a very slow analyzing step, you could consider these G1 particles as stationary. They're just sitting there. They're not moving anywhere. So we're going to consider those stationary and the G2 particles going through the screen very slowly. So here are 7 streams going through a slit with the G2 particles coming this way and G2 particles coming this way. Now I've rigged this up. Yeah, I'm rigging it. This is which says that although there may be a large number of G2 particles coming through, 9 of them are going to, because of that high quantity, 9 of them interact and push this G1 particle. Then there are fewer of them leaving this particle going towards this one, and it's going to have 8 G2 particles interact with the light. And there's going to be less, and so only 7 push these, interact here. 6 and 5, 4, 3, until it gets to the other end. In other words, the force of the G2 gravitational force gets less and less as it goes through the slit. Same thing happens this way. And I rigged this up so that it was the same as the other one. Everything's balanced, and so it pushes this way with 9 G2 particles push 8 G2 and so on across. What you have in the middle is this particle is being pushed equally. 6 pushing left, 6 pushing right, and it's going to go straight. It's going to continue to go straight. Whereas over here, you have 9 pushing right, 3 pushing left. You got 6 net particles pushing it to this center. You have the same thing over here pushing it to the right. And so you'll have in one slit where where the middle of the slit's in the middle of the light stream. You have this kind of bending happening caused because of G2. Now I'm going to show you a comparison here. I had a video on dark matter, and this involved G1 gravity, not G2 gravity. And what I showed was that as the G1 gravity particle passes through the core of the galaxy and then through open space and then the first arm and then open space and the second arm, the force of gravity, the Newtonian force, the G1 force of gravity, changes enough that it could explain the velocity at the edge of the galaxy. This is almost exactly the same thing. You could look at this particle right in the middle as the core of the galaxy. This is the first arm, this is the second arm, and there is a G2 gravitational force field set up from 6 to 5 to 4 in almost the same identical way. This is G2 gravity field here, and this is G1 gravity field here, doing exactly the same thing in the same way, except G1 particles interact with objects differently. They're different. The effect is different, and G2 particles interact with light to cause it to bend. So what you get with a single slit is you get this kind of a pattern coming up. This is an artist drawing I picked up from the internet, and the streams of light coming through here go straight. If you're just to the right of this, though, it comes over, crosses over, goes to the other side, and over here, comes here, bends more, goes over to here, and this one bends even more, goes there. Now, this is just my drawing. I just drew it to make the point. So that all these streams tend to bend on the right, tend to bend left, all the ones on the left tend to bend right, and the combination of this gives you the single slit pattern, so now with a double slit, did I jump one? No. To form a double slit pattern, you got the same thing, except that I'm having button trouble. In the center of this is where the G2 force field is 0. It's right around here, not over here and not over here. So these slits are offset, and because they're offset, there's a tendency for these to go this way and a tendency for this to go that way. And yeah, some of them are going to go more straight. Maybe some of them even go left. I'm not sure, but I drew it this way to show how these light beams cross each other in a double slit pattern. There's a slight tendency for this to bend to the right, even though they could bend both ways. Okay, this is not exact. This is just to explain that the G2 force field through this slit is causing them to bend, and they could possibly bend in this manner, giving an interference pattern. And if you go through one slit, 2 slit, 3, 4, 5. Well, this is 1, 2, 3, 4, 5, 7 slit. This is made using a diffraction grating, which is a very specialized slit. But you can see that they all end up the same way. And the particle model not only has to, if I go into more detail, has to be able to explain these patterns. It hasn't been done yet. A lot of work to do. So that is diffraction. Hopefully you have watched this and will continue to watch it, because I have one more video to go to. So please watch this. I'm going to challenge you again. If you've watched any or hopefully all of these videos, including the one I just presented on diffraction, that you will be able to explain the detector. There is a very interesting thing at the very end of that video by Al Khalili about a detector. You should be able to explain that. My name is Bobby Hilster, and I am your particle model guru. Tune in next time when I will explain more of the universe using the particle model. Thank you for your attention.